Welcome to the Cisco Netacad Introduction to Networks video series by Jason Johnson. This video is Module 1 of the Introduction to Networks for Netacad. Thank you for watching my videos. Your time is appreciated, and I hope they're helpful in the study of your course material. If you have any questions, you can leave a comment below, and I'll try and reply as quickly as possible. Let's start with Module 1. Module 1, Networking Today. Some of the things that we're going to cover in this module are how networks affect our lives, network components, network representations and topologies, common types of networks, internet connections, reliable networks. You're going to need to describe the 4 basic requirements of a reliable network. Network trends, explain how trends such as bring your own device, online collaboration, video, and cloud computing are changing the way we interact. Network security, and the IT professional explain employment opportunities in the networking field. That's all covered in this networking course. How networks affect our lives. We are connected together more than we've ever been in the history of humankind. Communication to us is almost important as air, water, food, and shelter. You know, internet connection, network connection, human connection, just being able to speak with each other. In today's world, we use networks, and we're connected just like we have. I mean, we've never been able to, in the history of mankind, to be able to send messages instantly from Europe to North America to South America to Asia. Just all over the world, we can send video, we can send messages, we can communicate with each other, we can translate languages now through software. It's just an incredible time to be alive. We have no boundaries with our networks. We have a world without boundaries at this point, really. We have global communities, and we have our human networks as we come together and communicate. Now let's take a look at network components. When we look at network components here, we have host roles. Host roles, every computer on a network is called a host or an end device. That's every computer, whether it's a mobile device or a laptop or a desktop or an iPad. Those are all called a host or end device. Servers are computers that provide information to end devices. Those can be things like email servers, a web server serving up a web page, a file server, and then clients. We have servers, and then we have clients. Clients are computers that send requests to the servers to retrieve the information, such as like a web page or an email from an email server. And we have the server types and descriptions here. We have the email, the web, and the file. File servers store corporate and user files. Webs runs web server software so we can host web pages, and then email is so we can email and communicate with each other. Next, we have peer-to-peer. It is possible to have a device be a client and a server in a peer-to-peer network. A peer-to-peer network is just, this is one peer, this is the other peer, and they can connect to each other. It's only recommended for very small networks, maybe 2 or 3 computers, 4 computers. I really don't have many peer-to-peer. I don't set up many peer-to-peer devices anymore. I usually put some type of switch in place. Even a small switch is not too expensive anymore, and I'll have the devices use a switch. Just it's easier to connect them all. But you can connect to, and in this case right here, we have this computer or end device. We have it hosting the print sharing, and this one over here is hosting the file sharing. And this computer can request over here. So they can act as a client and server in this case. And so this one can request files from over here. This one can request a print job. This one has the print server on it. And so it can send a print job over here and then print it out to the printer. The advantages of that are they're easy to set up. There's no routers, no switches, anything like that to set up. They're less complex because we don't have all the intermediary devices. They're lower cost because we don't have that equipment. And they're used for simple tasks like transferring files, sharing printers, things like that. The disadvantages, there's no centralized administration. They're not as secure. They're not scalable, and they have slower performance. Now, when we're talking about end devices, it's where messages originate from where it's received, or an end device is where a message originates from or where it is received. Data originates with an end device, it flows through a network, and then arrives at the end, and it arrives at the end device. Can't say that properly. So you have a local area network here. You're going to send a message through, and then it goes through this internetwork here, this series of routers. This could be the internet, or it could be a wide area network on a college campus, and then it sends it through those routers there, and then it goes to the other LAN and requests information back and forth. Now let's take a look at intermediary devices. What you're going to see when you work with Packet Tracer, or when we're working with Packet Tracer in my classes and in your classes, you're going to see these icons in the Packet Tracer area, and those are represented by these different types of icons. The intermediary devices are going to look like this. You're going to see switches, wireless routers, firewall appliances. Those are devices that interconnect end devices together. They include switches, wireless access points, routers, and firewalls. Management of data as it flows through a network is also the role of the intermediary device. They can retransmit the signals. So if a signal's getting weak, if it's coming to the switch, it takes the signal and retransmits it and sends it back out at a good signal strength so that it doesn't get lost. They can maintain information about what pathways exist, and they notify other devices of errors and communication failures. Now, when we look at network media here, network media allows communication to it transfers, or it allows the communication across to be connected. It's the connection. It's the connection points. I kind of look at if I use the analogy of a delivery truck. So you have a delivery truck with packages on it, and you're going to learn about packets, and you're going to learn about information. The delivery truck's carrying that information. The highways or the roads that truck is driving on is your network media. That's how it's going to get where it's going. It needs to have some way to be able to travel, and I use that as an example for that. That can be metal wires with cables, usually copper. With cables, those use electrical impulses. You have glass or fiber optics, or you probably heard the term fiber optic cable before. Those use pulses of light. And then you have wireless transmissions. Those are things like you've heard Wi-Fi, Bluetooth, and those use some type of wireless. They don't have an actual physical connection. They're connected through either radio waves or you can send them through. There's laser. There's all kinds of different wireless that you can use. Now, network representations and topologies. Network diagrams are often called topology diagrams. They use symbols to represent the devices within the network. Important terms that you need to know: network interface card, or you'll hear it called a NIC card, NIC, NIC. That's a network interface card that allows you to connect to the network. All devices that are going to connect to an internet have to have a network interface card. Whether it's a wireless device or a physical device, it's got to have some type of network interface card that interfaces between the system and the network. You're going to have some type of physical port. So you, on a physical or on a wireless, you're not. But on a wired or fiber optic, you're going to have a physical port. And then those you'll also sometimes hear interface. And so sometimes the term port and interface are used interchangeably. So you might hear the term port or you might hear the term interface. You'll hear the term interface a lot with the Cisco operating system, and then when you're doing all the commands, it'll say go to this interface and put this in. But then other times you'll hear port, but those are kind of the same thing. So you've got your representation here of end devices, desktop computers, printers, video, what they call telepresence endpoint, but video monitoring or video, two-way video. Intermediary devices, these are connection points. We talked about those, routers, switches. And then in the packet tracer or in the networks, you represent different types of media with the different visual here. The wireless media, because that's radio waves, so those bounce up and down. So that's got the bouncing. And then LAN media usually is a black line or a blue line, or blue line is usually your connection, or black line is usually used for the Ethernet lines. And then you'll have your WAN media, and you'll learn more about those in Packet Tracer, but those usually have a little lightning bolt on those. Now, when we talk about topology diagrams, you have two different types. You have a physical and you have a logical. The physical illustrates the physical location of the intermediary devices and the cable installation. So if we look on the left here, we see that we have our server room, so it's telling us where it's actually located. This one most likely is located in the second or on the second floor in room 158. And so we're saying, that's, usually that's how numbering works. It may be somewhere else. Whoops. Need to go back here. But this one's located physically on the second floor in room 158. It tells us that that's the web server. That's in rack number 2, shelf number 1. That router number 1 is in rack 1, shelf 1. So we can take this topology and go find that equipment physically where it is. That's why it's called a physical topology. And then we have our logical topology. That tells us, it shows us our devices, our ports, and our addressing scheme for the network. This is more important when we're talking about we need to know what ports are connected. We know where they're located because we've got our physical topology, but now we're representing our local area networks and our networks connected together here, our intermediary devices that we have here. But now we're showing our physical devices, but now we're showing our ports or our interfaces that are connected there. It's showing our IP addressing scheme so that if we need to look that information up. Rarely you'll see these two overlaid together. I've seen sometimes where you'll have the logical and the physical on the same layout, but usually you're going to have those separated. Common types of networks. Some of the common type of networks that we have, they come in all different sizes. You have maybe a small home. Here in my house, I have a small home network. I have 2 different wireless routers. I have a switch over here on my desk that I use to connect my computer and my laptop. And then I've got some wireless routers that I connect my phones to, my other smart devices, different things like that. Then you have a small office, home office. That's usually when you're going to have multiple people working out of a small office or what we call a home office. That's almost what mine is that I have set up here at my house. It's almost a home office, but it's not quite because I don't have a server. I don't have everything totally networked together. I've just got it all kind of tied together with wireless routers. And then you have the medium to large. You've been, in a college campus or in a big building or something like that. It's usually a medium-large network. And then you got your worldwide. Think of the internet on that one when you're talking about the worldwide. That's a large network. And you can have multiple worldwide networks. So you can have big, large networks in a country or in a city or a state. And then those can be connected to other networks. And then those all connect into the worldwide or what we call the internet. Now, a couple of terms that you do need to know, LANs and WANs, local area networks and wide area networks. You're also going to hear the terms, it's not on these slides here, but you need to know there's some other ones as well, MANs or metropolitan area networks, CANs or campus area networks. So you have LANs, WANs, MANs, CANs. You have PANs, personal area networks. So those are some of the other area networks. You might want to look those up. They're not on these slides. They're not in this video here other than me just talking about them. But you might want to look those up because it's good to know those as well. A LAN is a network infrastructure. They do vary greatly. The size of the area covered, the number of users connected, the number of types of services, and the area of responsibility. And then the 2 most common type are LAN and WAN. So when we look over here on our representation, a LAN is yellow, WAN is in this little purplish color here. And the home office here, we're looking at, that's a local area network. We've got 1 intermediary device and we have some endpoints. A WAN, if you'll notice, has all intermediary devices. This is when you go, you're going to have some labs and you're going to probably have some questions on needing to know how many LANs you have and how many WANs you have, or just how many local area networks you have. So if we were looking at this one here, I've got 1 local area network here. I've got 1 WAN here, wide area network, because I have my intermediary devices. A good way to tell these apart, and it's not always the case, but a good way that I use to tell it apart is if I have end devices in here, that's usually a local area network. And then when it's just intermediary devices, that's a wide area network. So a LAN is a network infrastructure that spans a small geographical area. It can be in 2 different buildings. It can be in multiple buildings, but it's usually confined to 1, maybe 2 buildings, small area. A WAN is a network infrastructure that spans wide geographical areas. So you can have multiple LANs connected together, and then those become WANs, wide area networks. So you might have two. Let's just use. I'm going to use a college campus, and let's say we have 4 buildings on my college campus, and each building has a different WAN, or excuse me, each building has a different LAN. So we have building 1, building 2, 3, and 4, and you connect all those together, and those become one wide area network. Or it could be a campus area network, but it's just as easy to call it a wide area network as well. Now, the internet is the largest wide area network that we know of. It's made up of hundreds and thousands and thousands and thousands of local area networks that connect to the wide area network. And it's connected in all different types of ways. Through copper, wireless, they have big cables running on the ocean floor. We can send signals into space and bounce them off of satellites and then send them back down. We connect in all different types of ways. The internet is not owned by an individual or group. It's not owned by a country. It is shared internationally. The following groups were developed to help maintain the structure: the IETF, the ICANN, and IEB. I would recommend going and checking those out. Maybe go to Wikipedia and check those out. Yes, a college professor is telling you to use Wikipedia. Wikipedia is perfectly fine to do research on. Just don't use it for your sourcing. And you might go check these 3 out because you might see those again on an exam somewhere. Just good to know what those are. There's some the ICANN, IETF, and IAB. Now, you need to know about intranets and extranets. An intranet, and not internet. Notice the difference here. Intranet, it's a private collection of local area networks and WANs. So let's just say a big company like Cisco, and they've got some buildings tied together, and they've got their different organizations, internal organizations tied together. That becomes, and it's just internal to Cisco. That's intranet. So it's a collection of LANs and WANs internal to the organization. So intranet, that's important to get that distinction. And then an organization might use an extranet, extra being out, extra, to provide secure access to their network for individuals who work for a different organization, but they need access to their data on a network. So we are accessing, when you log into the Netacad website, and I went forward there. When you're logging into the Netacad website, you're accessing the extranet through Cisco. And the internal that only Cisco has access to would be their intranet. And when you access that Netacad and access that material, you're accessing their extranet. Let's take a look at internet connections. So internet access technologies, there's many different ways to connect users. Popular services for home users in the United States include broadband cable, broadband digital subscriber line, or you'll hear DSL, wireless LANs, mobile services. Around the world, there's different types of ways to connect, but they're all similar to what we have in the United States as well. You might have cable that's run. You might run mobile services or mobile towers. Wireless towers that connect. But organizations do need faster connections to support IP phones, Internet Protocol phones, the phones that run video, or they're running phone service across the network. Video conferencing, data center storage, you're going to need more bandwidth for that. And then you have business class interconnections. They're usually provided by a service like an ISP or a service provider, or an ISP, Internet Service Provider. And those can include business DSL, lease lines, Metro Ethernet. Sometimes they put in fiber optics for businesses. Those are more expensive, but they're going to give you more bandwidth for your money. Now, home and small office internet connections, those usually are cable. Here at my house, I have cable. I have a company that I don't necessarily like, that company. They control a lot of internet and they control a lot of media. Not necessarily a fan of them, but they do provide reliable internet to me using cable. A DSL is high bandwidth. It's always on. It runs over telephone lines. And usually if you can't get cable, you can hopefully get DSL. You usually have to be within about 2 miles of what we call a demarcation line. Cellular and I always have trouble with this word, so sorry about this. Cellular uses cell phone networks, cell towers, to connect to the internet. You have satellites. You've ever heard of a satellite phone or satellite connections? When I was serving in the Indiana National Guard, or the guard, the networking guys would come out there, and gals, they would come out and they would set up the trucks, and they would connect to the military satellites, and we would have internet. Usually within 15, 20 minutes, we'd have internet up and running when we'd get to a campsite. And then you have the dial-up telephone service. I used to use those way back in the late 80s, early 90s. Used dial-up telephone service. I helped with a bulletin board system back in the early 90s, and we had a dial-up telephone service. We had modems. Those are usually inexpensive, but they're very low bandwidth, and you have to use a modem. You have to use you need a modem for cable and DSL there too, but these are lower-end modems. They're not very expensive, but they really low bandwidth. You're not going to be able to do video conferencing. You're not going to be able to watch videos, things like that. You're not going to be able to play video games. It's just not a lot of bandwidth. Now, business internet connections, those are going to have a dedicated lease line, some type of Ethernet wide area network, or WAN, a DSL, or satellite. Those are going to be, again, more expensive, but they give you more bandwidth. Another term you need to know is what we call the converging network. Before we had converged networks, an organization would have had separate telephone, video, and data. Back in my early days of working in IT, we had a phone system, we had a network system, and we didn't have video back then, but we had a data system and a data network, and we had our T1 leased lines, and then we had a telephone system that come in on different lines than our data lines come in on. And now, we are what we're calling converging networks or merged networks. They do use different rules and standards now, but they, instead of having like computers and phones and video and all of them coming in different, they are all converging now. So our data, voice, and video are all going through the same medium, and we have a rules agreement standard, and those messages are all being sent across the same medium and the same intermediary devices. It's what we call a converged network. They can deliver data, voice, video all over the same network infrastructure. So your same Ethernet cable that you're using your computer for, you can pick up your phone and use the same cabling or video. Now, when we talk about reliable networks, we have network architecture. One of the things that we're responsible for in the networking IT world is making sure data is available. And so we have to have network architecture that is fault tolerant, scalable, it's secure, and it has a quality of service. So those are some terms you need to make sure that you understand: fault tolerance, scalability, quality of service, and security. Let's take a look at those real quick. Fault tolerance, that means that the network fault tolerance network limits the impact of failure by limiting the number of affected devices. So multiple paths are required for fault tolerance. So we see we have multiple paths here. You see them right here on there. So if this router right here goes out, traffic can be routed this way and still work. Maybe slower, but you're still going to get your network through. Provides redundancy by implementing a packet switch network. So packet switching splits traffic into packets that are routed over a network. And each packet could theoretically take a different path to its destination. Scalability. A scalable network can expand quickly and easily to support new users. So let's say that we had our network here, and now all of a sudden we need to add more users in. We're going to ramp up, and we got to hire 3 new people over here. So we're going to put this switch in. We're going to tie this switch into this router and then put the endpoints in. And just in a couple of days, well, it wouldn't even be a couple of days. Within a few hours, we could have new computers and a new switch onto our network and have those configured and up and running. Quality of service. So for voice and live video transmissions, they do require higher expectations for services. So if you've ever watched a live video feed and it breaks in and out, if you've ever watched Mixer, or if you watch Twitch or watch some of the video gaming and every now and then it breaks in and out on you, that's quality of service. And so quality of service is a primary mechanism used to ensure reliable delivery of content for all users. It's critical for business operations. So if you're watching a video game on Twitch and you miss part of the action, it's no big deal. But if you're on a video call and you're trying to work out a new contract with a customer, it is important. So quality of service policies in place. The router can more easily manage the flow of data and voice traffic. So you'll learn more about quality of service in later courses and in material. And then we have network security. You need to have security on your network because if somebody breaks into it, they can get your information, they can shut things down. It's just, you're not going to have a good time if you don't have good network security. So network security includes physical security. So when we hear about hackers and we hear about, network security, we don't always think about the physical security, but locking up those routers and switches in a network closet and putting a lock on it and having cameras in place, it's important. So it does prevent unauthorized access to the devices. The information security needs to have protection of the information or data transmitted over the network. And then 3 goals of network security are confidentiality, integrity, and availability, CIA. If you go into cybersecurity, you're going to see those 3 terms a lot. But you've got confidentiality, only intended recipients can read the data. Integrity, assurance that the data has not been altered during the transmission. And availability, making sure that the data is available for the authorized users. Now let's take a look real quick at recent trends, and this video is being recorded in April 2020. But some of the recent trends in networking are bring your own device. You'll see a BYOD. That's a bring your own device. That's where for example, I have my own phone, and I connect to my work. I get my email through my work. And so I have to bring my own device. They put some security software down on my phone, making sure that it's locked and some different things like that. But you have to make sure that if users are going to bring their own device, that they can be able to do that. It can be anything from a laptop to a netbook to a tablet, smartphones, e-readers. It's just you have to work with your company or your network and figure out what is going to be allowed as a bring your own device, personal devices. When you hear the term online collaboration, that's just that you can work with others. Cisco has WebEx, that's shown here, where we can connect together. There's some other, during the year of 2020, that's where everybody started connecting and online collaborating like we've never done it before. And so Cisco has the WebEx, one of those pieces of software and platforms for that. It allows for high priority for business and in education. WebEx Teams is a multifunction collaboration tool for businesses. You can send messages, post images, post video and links and things like that. Now, video communication, that's video calls are made to anyone regardless of where they're located. Video conferencing is a powerful tool. You can use that as part of WebEx, but there's also Cisco Telepresence. You have telepresence hardware for that. Another term that you're probably familiar with is cloud computing. If you're not familiar with it, cloud computing just allows us to store files and data on the internet. So applications can be accessed using the cloud. They allow businesses to deliver devices anywhere in the world, or to deliver to any device in the world. So I can put a Dropbox, I can put my files up onto a web server and back them up. I can use Google, I can use Amazon services, I can use Microsoft services, Cisco services, and put those up in the cloud. It is made possible by data centers. Small companies that can't afford data centers lease server and storage services from larger data center organizations like Microsoft and Cisco and Amazon that provide those services. You have public clouds. Those are usually available to the general public through a pay-per-use. Private clouds, those are usually like the government or specific organizations. Hybrids can be a combination of those. And then you have custom clouds, such as like healthcare or media. They can be either private or public. Now, some of the technology trends in the home. We have smart technology. Our cars, let me go back. Our cars are connected to our phones, and our phones are connected to our homes. My phone is, I connect it to my car using Bluetooth. I tested it out the other day. I left a reminder on my phone, and I said, remind me when I get home to take out the trash. So as soon as I pulled into my home, my phone realized I was in the location of my home, and it popped up, and it went across I've got a home device, and it popped up and says, hey, we've got a reminder for you that you need to take out the trash when I walked in the door. And the device there in the house said that to me. Everything from ovens. You're going to hear Internet of Things in this course at some point, and that's what we're talking about. Ovens, washers and dryers, refrigerators, different things are being connected now through technology in the home. Another term, this was used a lot, but it's called power line networking. You can use the existing copper power lines in your house, and yes, it's possible. Even though those are carrying electricity, you can also send networking across those same copper lines that the electricity is being carried on. I know it's really crazy to think about that, but you can do that. So the power line connection, you can put an adapter in, and then it can... Yep, I went ahead again. And so you can have your wireless router, it can connect in, and then it sends it a repeater to somewhere else in the house. So those are available. You have wireless broadband. That's in addition to DSL and cable. Wireless is another option. So security threats, network security is an integral part of networking regardless of the size of the network. You need to make sure that firewalls are in place, that network, security is in place. Cisco does a really good job of having training for that. There's a whole track in there for security. You'll hear the term threat vectors. Those might be external or internal. You can have internal threats. You could have somebody bringing a USB drive in and plug it into their computer, and it's got viruses on it. Or you've got a user that goes to a site they're not supposed to go to, and it's got malware on it. And the IT networking people are responsible for making sure that doesn't happen. You can have everything from denial of service attacks, where they send so much traffic to your web servers you can't get anything through, or your network. Zero-day attacks, spyware, adware, viruses, identity theft, lost or stolen devices, accidental misuse by employees or malicious employees. You can have employees that do bad things on purpose. So some of those security solutions, they might implement multiple layers, physical layers, cameras, door locks, antivirus software, firewalls in place, things like that. Larger networks are going to have dedicated firewalls, access control list, intrusion prevention systems, or IPS, and virtual private networks. Now, the last thing we want to look at here is the IT professional. You have the CCNA, which is probably what you're working towards, but then you have different tracks with Cisco. You have the CCNP, the CCIEs, and there's a lot of different areas in the CCIE, but and then you have DevNets. You have the Associate Specialist, Professional, and Expert. Get with your instructor for this course to talk about more about certifications, or you can go to the Cisco website for that as well. You also want to check out networking jobs. As I've counseled my students, there's not going to be any lack of IT jobs in my lifetime. I'm over 50 years old, and I would guess, the next 50 to 100 years, there's going to be IT jobs and there's going to be networking jobs. It's not going to go away anytime soon. We're still connecting things together. It's still it's still advancing and improving, and so you're going to need people to connect all that together. And there's a lot of people in IT and networking that are going to be retiring in the next 10 to 15 years, and so those jobs are going to be out there. All right, so what did we learn in this module? We learned that through the use of networks, we're connected like never before. All computers that are connected to a network and participate directly in network communication are classified as host. We learned that diagrams of networks often use symbols to represent the different devices and the connections that make up the network. A diagram provides an easy way to understand how devices connect in a large network. The two types of network infrastructures are local area networks, LANs, and wide area networks. SOHOs, small office, home office, DSL, cellular, satellite, business internet connections. Network architecture refers to technologies that support the infrastructure and program services. The four basic characteristics of a network architecture are fault tolerance, scalability, quality of service, and security. Recent networking trends are bring your own devices. There's several common external and internal threats to networks. Larger networks have to have extra layers of security, dedicated firewall systems, VPNs, virtual private networks. And then we also took a very brief look at the certifications. Okay, thank you for watching this video. Subscribe so that you can get alerted when I put other videos up. Or if you have any questions, you can leave me a message down in the comments, and I'll try to get back to you as quick as possible. Hope you have a great day, and be excellent to each other.